Hello guys, hello once again to our remedial classes for hosted by Mewa. Mewa itself located in Mombasa. So today we'll be conducting a session of chemistry, and the first topic that we'll be dealing at or we'll be looking at will be structure of the atom and the periodic table. And the reason why I chose this topic is because most of the questions usually originate from this topic. So if you don't know what an atom is, how it looks like, what are the subatomic particles, what is a periodic table, what constitutes a periodic table, and everything in that, including the balancing of equations, is usually very important and very crucial during your KCSE exams. So the first thing, since I didn't write what an atom is, but still I'll define what an atom is. Okay, an atom, an atom is usually the basic unit. For example, like a cell. A cell is the basic unit of life, right? And an atom has just the same definition as a cell. Okay, so an atom is the smallest particle of a chemical element that can exist and also take part in a chemical reaction. So I repeat it again, an atom is the smallest particle of an element, or it can be also a compound that can take part in a chemical reaction. And usually the atoms are the one that take part in a chemical reaction. And that is the reason why it is very crucial for you to know what an atom is. So it's different from an element, it's different from a molecule, it's different from a compound. So if someone was to ask you what's an element is also the smallest one, is a substance that cannot be split any further into simpler substances. So for example, sodium is an element, but sodium you can't split any further because in itself you just have sodium. Okay, so you can't, if you split it, you can't get a sub sodium and etc. So you just have a sodium element, and a combination of two or more elements is what we refer to it as a compound. So for example, you take sodium, you react with chlorine, you get sodium chloride. Another example may include like iron and chlorine, you get iron trichloride, or you can have a sodium plus oxygen, you get sodium oxide or sodium peroxide, depending on the amount of oxygen that it reacted. So let's delve into subatomic particles of an atom. So inside an atom, we have three subatomic particles. And just like you see on this presentation, we have protons, we have neutrons, we have electrons. Now, if someone was to ask you what a proton is, what a neutron is, what an electron is, then you define it this way. For the first point, we have protons. Protons are usually positively charged particles found in the nucleus. And neutrons, from the word neutral, so those are neutral particles found in the nucleus. So two subatomic particles are found in the nucleus, and that includes protons and neutrons. The one that is found orbiting around the nucleus through the energy level. Now, in that atom, we have nucleus, and in the same atom, we also have electrons. But now, where are electrons found? Now, around that nucleus, there's an orbit around it, and that orbit we refer it to as energy level. And inside that energy level, we have electrons, and electrons usually move. So electrons from electricity, they're usually negatively charged particles orbiting the nucleus, and these particles are the reason why you get electricity most of the time, because without free mobile electrons, you might not get electricity. Okay, so electrons are negatively charged particles orbiting the nucleus. Sometimes you might be asked a question from KCSE, and they might ask you name the subatomic particles of an atom and state their respective charges, and I hope so you can answer that well, since I've already discussed it with you. Let's go to our next slide. Now, Inside an atom, we have some definitions, or we have some terms that you should supposed to know, or you should be supposed to define it, and that includes atomic number, and we have mass number. Atomic number is just the number of protons in an atom, so it doesn't include the neutrons, it just includes the protons only. So atomic number is just the number of protons in an atom, while mass number is now the summation of protons and neutrons in the nucleus. Okay, summation of protons and neutrons in the nucleus. It doesn't include the electron. The reason why we don't include the electron in it is because electrons are very insignificant in mass. So their masses are usually very insignificant in that sense, in a way that it's your mass the mass of an electron can be around can be around 0.000, which is insignificant, which is a insignificant value. So for you to get mass number, you just take the summation of protons and neutrons in the nucleus. Okay, hope we've understood till that part. Atomic number, same thing. Now sometimes you might be asked what atomic mass is. Atomic mass is just the mass number. So if someone wants to ask you what atomic mass is, atomic mass is usually the summation of protons and neutrons in the nucleus. So now we have a symbolic representation here, and that's and on the screen you see a carbon atom, right? There's a carbon atom, there's a number up, there's a number down. Okay, the number which is up, there's a number which is down, but I think it's been written wrongly. The 12 should be up and the 6 should be down. Okay, the 12 being up represent the mass number, and the 6 being down represent the atomic number. So just rectify it in case I'm rectifying it for you. So just know that 12 is up and the 6 is down. So the 6 is usually the atomic number for carbon, and the 12 represent the mass number for carbon. So in case someone wants to ask you what is the number of protons or neutrons, the number of protons is 6. The number of neutrons, how do you get the number of neutrons? You usually, for you to get the number of neutrons, you usually take your mass number minus atomic number. So if your mass number is 12, your atomic number is 6, you just take 12 minus 6 to give you 6 neutrons. Let's take another example. Okay, let's take another example. For example, let's say oxygen. Let's say oxygen has an atomic number of 8, so it has 8 protons in it. Mass number, oxygen has a mass number of 16. So if someone was to ask you what is the number of neutrons inside oxygen, you just take the mass number of oxygen, which is 16, minus the atomic number, which is 8, and you get 8 protons. Okay. Okay, I hope you've understood, because protons plus neutrons is just equal to your mass number. So there's a question like that. Identify elements X, Y, and Z based on the number of protons and neutrons and electrons. So you can pause the video if you want so, and just take a moment for you to answer this type of question. Now we have the first 20 elements of the periodic table. Now we are entering the periodic table. So you'll have to pardon me because I don't have any diagram to represent it, but inshallah in the next class I'll try my best to show you the periodic table itself. So the first 20 elements of the periodic table include the first one being hydrogen, which stands for the capital H, the second one being helium, standing for the He, and third one is lithium, Li, fourth one is beryllium, Be, fifth one is B, boron, sixth one is C, carbon, seventh is N, nitrogen, eighth stands for oxygen, which is O, F, the ninth one is F, fluorine, the 10th one is Ne, which is neon, 11th one is Na, which is sodium, and the 12th one is magnesium, which is Mg, The 13th one is aluminum, which is Al. 14th is silicon, Si. 15th is P, which represents phosphorus. 16 is sulfur, which represents SS. And we have 17th chlorine, Cl. 18th argon, Ar. And 19th is potassium, which is represented by letter K. So the 20th one is calcium, which is represented by Ca. So from these 20 elements, you'd see that some elements that don't align with the naming of the actual element. So for example, let's say we have sodium in the 11th position. Sodium is written as S-O-D-I-U-M, sodium. But now when you write it as a formula, or if you write it as a chemical formula, you write it as Na. The reason being is because sodium's real name is not sodium, but instead comes from a Latin name called natrium. So this is something that you should know. The same thing with potassium. We don't write Po, we write potassium as K because of its Latin name. So this is a homework for you. Just tell me what K represents in Latino. Okay, so you can now sit by yourself and now write those elements down, and then try to memorize them and get to understand them, because mostly chemistry is not about memorization, but it's most about understanding the concept in that specific topic. So with that, let's continue to the next slide. But before we proceed to the next slide, there's an easy way for you to know this 20 elements. So there's a student that told me an acronym, so which I'm also telling you as well. So the acronym starts like this: hey, listen, BBC News on Friday night. Somali president accuses Somali minister selling cabbages at police canteen. So hey, from the word hey, first one is hydrogen, second one is helium. So that's how you get the names from these acronyms. And I think you can practice using this acronym, and it might help you for exam purposes or for reference purpose. Okay, then we have a subtopic called isotopes. Now, people usually confuse a lot of things here, especially when it comes to isotopes and allotropes. Now, allotropes is different from isotopes, and we studied that when we reach the topic of carbon and its compound, where we'll discuss what an allotrope is, what are the allotropes of carbon, and etc. But for now, we are at isotopes, and we should know what an isotope is. Now, isotopes are just atoms of the same element with the same atomic number, but usually have different mass numbers. So let's take for an example. We have two carbons here on the screen. We have a carbon whose mass number is 12, and the other carbon, its mass number is 14. So those are just same elements. Those are atoms of the same element with the same atomic number. If you see, all of them have the atomic number of 6 and 6, but they just have a different it just has a difference in mass numbers. So if you see, for the first carbon we have 12 as its mass number, and the other carbon has 14 as its mass number. So that's the first way of defining it. So these are atoms of the same element with the same atomic number but different mass number. Another way of defining it is this way. So isotopes are also atoms of the same element with the same protons but different neutrons. Because if you see here, if the mass numbers are different, at the end of the day you'll find out that the neutrons will also be different in those atoms. So let's take an example. For the first one, we have 12 as its mass number and 6 as its atomic number. Now if you take 12 minus 6, which is mass number minus atomic number, you get 6, and 6 is it refers to the number of neutrons. So in the second one, you'll see its mass number is 14 and atomic number is 6. So if you take 14 minus 6, you get 8. 8 is the neutrons. Okay, so 8. So it has 8 neutrons and the other one has 6 neutrons. So that's another way of defining it. So by on time, you can also define isotope again, and you can give other 2 examples of carbon isotopes rather other than the one that I've shown you. But also try and get a time to give me different isotopes. Okay, we have a lot of isotopes apart from the carbons. Now, but before we proceed, I think there's an aspect which I've forgotten to explain, which includes the RMM and the RAM. I'm not sure if it is here. It's here. Okay, there's no problem. Okay, let's go to the other subtopic, which is energy levels and electronic configuration. Now, we just said what an energy level is. An energy level, it's just a pathway through which electrons usually occupy or pass through. So that's an energy level. So each atom or each element has its own energy level. Okay, we can't know how many energy levels it has. Some elements have same energy levels, but different electrons in the last energy level. Okay, so the maximum electrons per shell or energy level differ. Okay, they usually differ. Okay, let's say for the first energy level, it just takes 2 electrons maximum. It can't take more than 2 electrons. For the second energy level, it usually takes 8 electrons maximum. The third one takes 8 electrons as well. The fourth one, it usually takes more than 8, so it usually takes 18 electrons maximum. But now in the for this KCSE purposes, we just teach we usually look at the first 3 energy levels. We don't concentrate on the fourth one. So most of the time, since we just concentrate on teaching 20 elements, that's why the electrons, the maximum that you will see at the fourth energy level is just 2. So that is calcium. So a good example, we have sodium. Sodium has an atomic number of 11. Okay, has an atomic number of 11. And how do you know that? You just look at the positioning, its positioning in the first 20 elements, and you see that sodium is in the 11th position, so it has 11 protons. And if it has 11 protons, it will also have 11 electrons in a stable atom, because the number of protons equals to the number of electrons in a stable atom. So let's say it has 11 electrons. So if someone was to ask you to write its electronic configuration, right, it will be easy. Now you'll be wondering what an electronic configuration is. Electronic configuration is just how you put the electrons in its different shells. So it's the structure that you use to put each electron in its own energy level. So for this case, you look at sodium. Sodium will occupy 2 electrons at the first energy level. So once it occupies 2, you take 11 minus 2, which is 9. So you'll be remaining with 9. In the second, it will take 8. So from that 9 that you remain with, you'll just remain with 1, and the 1 will be in the third energy level. That is why its electronic configuration is 2.8.1. Okay, but we basically like students to write 2,8,1. Okay, so this is a question. Write the electronic configuration of magnesium. Write the electronic configuration of magnesium. I'll just use this. Okay, then. So we have magnesium. Magnesium is written as Mg. Okay, magnesium. How many atomic? What's the atomic number of magnesium? If you look at it closely, hey, listen. BBC News on Friday night, Somali minister. So 12th position. Okay, 12th position. So it means that it has 12 electrons. Okay, so it will take 2 in the first energy level. It remains with 10. The second energy level will take 8. It will remain with 2, and then the last 2 will be put in the last energy level. So you write it as 2, 8, 2. Hope you've understood that. Okay. So I did put a diagrammatic representation of electronic arrangement for this case, but still you can find a diagram. Okay, but let me draw one just in case. So let's say let's use oxygen as our reference. Oxygen, we said it's eighth. It is in the 8th position, therefore it will have 8 electrons. So when you draw it, oxygen here. Okay, this is just the nucleus. This now is your first energy level. Then we have second energy level. Okay. So in the first energy level, it usually takes 2. Okay. And in the second energy level, it will take 6. So 1, 2, 3, 4, 5, and 6. So and that's how you draw oxygen atom. Okay. So using a diagram which has shown it, this is just a question for you. Find time to do it by itself. So using a diagram, show the distribution of electrons in a fluorine atom. So I'm just giving a hint. Fluorine is how much I hate this NBPC news on Friday. So Friday, which is 9. So it has an atomic number of 9. So just just find time, or you can pause the video and draw it by yourself. Now we have periods and groups. I might just draw it for you to look at it. So this is usually a period. It's just a diagrammatic representation, but it's not the exact thing. So I'm just showing you how it looks like. Okay, that's usually big. One, two, three, 4, 5. I'm just showing you, but usually it doesn't look like this. So this is just an example. So usually the ones that are on the horizontal row, which is this way, is usually the periods. Okay, it's usually what the periods. The one on the vertical rows, which is this ones, are usually the groups, and usually the groups are written in terms of italics, not italics, but Roman numbers. So you can have group 1, group 2, group 3. So make sure groups should be written in Roman numbers, group 4, and etc. until you get group 5. For the periods, you can write it in terms of number: period 1, period 2, period 3, period 4. Okay, that's just an example. So the horizontal rows represent the periods. So, but it also represents the number of energy levels. So let's say we have an element K here. Okay, so if someone was to ask you write down its electronic configuration, basically it's very easy. So you just look at where the group is. Now the group represents for the valence electrons, or the electrons that are found in the outer shell. So it is in group 3. So K is in group 3. But which period? It's in period 4. So you write it as 2, 8, 8, 3. Okay, because so this is period 4, but group 3. So let's take an example, element X. Element X has an atomic number 13. Okay, so identify its period and group. Sometimes it might be given the atomic number. So that 13 protons equal to just 13 electrons. So how do you write its electronic configuration? It writes as 2a3. So the outermost shell is this. Okay, so it has 3 electrons, therefore it will be in group 3. But now if you see the number of energy levels, we have 3 energy levels, therefore period 3. Okay, hope everyone has understood that. Now we have relative molecular mass and isotopic composition. So usually if you're studying isotopes, you need to know also how your RMM is found out. So different isotopes will have different RMM. Okay, but the average mass, which is the RAM, the relative atomic mass, so is how is found out. How do you find it out? It's very easy. Okay, so usually for this type of question, you have chlorine, 75% of it, Cl with a mass number of 35. The other Cl has a mass number of 37 with a percentage composition of 25%. So we just do like 75% multiply by 35. Okay, then add it to the 25%. Okay, multiply by 37. Then you can divide it by 100. Okay, so at the end of the day, you'll find out that you'll have 35.5. Usually, the largest percentage composition, usually, if you look at your RM is this one, it should be nearer to the one with the largest percentage composition, which is 35 itself. Okay. No, okay. Take a moment also find out questions on this. You have made familiar chemistry, so I think you as a student of knowledge can find as many questions as possible. Okay, now we have ions, right? An ion is just a charged atom. If someone has to ask you an ion, what's an ion is, it's just a charged atom. That's why it's a simple definition. So a charged atom can either be positive or negative. So if it's a positive atom, if it's a positive charged atom, we call it a cation. So a cation is usually a positive charged atom. Okay. If it's a negative charged atom, then we refer it to as an anion. Okay, so let's take an example of sodium. Sodium electronic configuration is written as 281 because it has a proton or atomic number of 11, so it's 281. So you just look at this, the last one. So atoms usually have a tendency, one reaction, they usually have a tendency of either losing or gaining electrons. So for this case, we have one at its outermost energy level. So it can gain, obviously. So there are two options. It either gains 7 electrons for it to have 8 electrons, so to occupy the whole energy level, or it loses 1 electron. And which one is quite easy? Basically, losing 1 electron. So when it loses 1 electron, it will have 8. Okay. So rather than now writing as sodium itself, it will change to sodium plus. What does the plus show? The plus shows or indicates that the sodium has 1 more proton compared to the electron, because initially it had 11 protons and 11 electrons, but since it lost 1 electron, it just remained with 10. But for the protons, it doesn't change, so you just still have 11. So if you look at it, 11 plus 11 minus 10, we say that the electrons are usually negatively charged, so if you add them, you still have plus 1. So you just have an extra proton in your ion. So if you are to draw, so this is, let's say, sodium. Okay, this is sodium ion now. Okay, so sodium ion 2 and we draw it like this with a charge. Okay, so very easy, not that hard. So if let's say, for example, oxygen has an electronic configuration of 2,6. Okay, listen, BBC News on, yeah, 2,6. So for oxygen, he usually doesn't lose, because you look at the easier side for you to have an energy level filled up with electrons. You either gain 2 or lose 6. So it's better to lose to gain 2, which is easier. So you gain 2. So once you gain 2, it means that you'll have more electrons compared to protons. As a result, you don't write it as plus, but instead you write it as 2 minus, to show that you gain 2 more electrons, and the electrons are greater than the protons by 2. So very simple. But when you draw it, remember, when you draw it, you have to I think we'll end that topic for now. Let's just continue the session. If we reach chemical bonding, that's when I will explain it more in a deeper cross-section manner. So valences of metals and non-metals. So metals, we have group 1, group 2, group 3. Usually metals are those elements with a valency of either 1, 2, or 3. Okay, so that is from group 1 to 3, all of them are usually metals. For non-metals, they tend to have a valency also 1, 2, 3. But now for non-metals, they usually gain electrons rather than losing. For metals, they lose electrons. So those with group 1 to 3, all of them are metals. From group 4 to 8 are usually non-metals. So with the example of chlorine is in 287. We have oxygen 2,6. We have nitrogen. We have a lot of non-metals in our periodic table. So basically, you need to know all of that. So aluminium has a valency of 3. Oxygen has a valency. So aluminium is written as 2A3. So obviously it has a valency of 3 because it loses 3 electrons. Oxygen has a valency of 2 because it gains 2 electrons. Okay, chlorine has a valency of 1 because it what does it do? It also gains 1 electron. So very easy. But oxygen and chlorine are usually non-metals, while aluminium is a metal. So radicals, and I think we're approaching the end point. So radicals and their valences. Radical are usually group of atoms acting as one unit. Okay, someone wants to ask you what a radical is, you just tell them this is usually group of atoms acting as a one unit during a chemical reaction with a charge. Remember, with a charge, usually have charge in it, with a charge. So OH minus, these are a group of atoms which include oxygen and hydrogen, but during chemical reaction they usually react as one thing. They don't react differently. So the same thing with sulfate, the same thing with carbonate, and all of them have a charge. The charges represent the valences. So for example, for OH, it has a charge of negative, so it means the valency is 1. So for sulfate, it has a charge of 2 minus, so the valency is 2, the same thing. So we also have other radicals like nitrates. We have hydrogen sulfide. Okay, we have many other radicals that I can say here. We have phosphates and etc. So if you get time to say the others, you can search it in your book and you find many of them. Okay, oxidation numbers, usually it's just a charge an atom appears to have in a compound. So for group 1 it has +1, group 2 +2, the same thing. It is similar to iron, but now the difference is for groups, for ions you usually write as 1+, but now for For oxidation state, we write it as +1. You start with the plus or the negative parts first. So for example, we have this question: what's the oxidation number of sulfur? Okay, oxidation number of sulfur. So the oxidation number of hydrogen, you already know it. For one hydrogen, you have, I think, +1. +1, yeah, because it loses an electron. So +1. Then since it's 2, you multiply by 2. For oxygen, oxygen will be -2. Okay, -2 because it gains 2 electrons. Then multiply by 5 because it's for oxygen. So let's just write it here. So 2 times +1 plus your sulfur, which is X, plus 4 times -2 will be equivalent to 0 because it's a stable atom, it's a stable compound. So 2 times 1 is 2, plus X, 4 times -2 is -8 equal to 0. So you have 2 plus X minus 8. We'll have 2 minus 8 as -6 plus X equal to 0. So our X is +6. So the oxidation number of sulfur is +6. Now, linking ions, valence and oxidations, the numbers, I think this one's it's just the same thing, but that's what we discussed. Okay. Chemical formula of compounds. Chemical formula of compounds. Okay. So this is very, very crucial. Sodium. If someone was telling you to write sodium and chlorine, it gives you sodium chloride, right? So writing those chemical formulas are usually easy. So you write sodium and we write chlorine. Now the ion for sodium is written as sodium plus. The ionic state for chlorine is written as chlorine minus. So usually the sodium interchanges. It will take that negative part and chlorine will take that positive part. So it will become sodium chloride. It just takes the number. Okay. So let's take an example: calcium and chlorine. So calcium and chlorine, calcium chloride. So calcium is 2 plus, chlorine is Cl minus. So the calcium will take the minus of this one, not the minus but the number, which is 1. So calcium become 1, and the chlorine will take the 2, which eventually becomes 2. So we have CaCl2. So let's look at this question as well. So write the formula for the compound formed between aluminium and oxygen. So aluminium is written like this, oxygen is written like this. Obviously the valency for aluminium is usually 3, okay, because aluminium electronic configuration is 2a3. So the valency is usually 3 plus 3, but you write it as 3 plus because it loses. So oxygen is 2 minus. So the aluminium will take the 2 and the oxygen will take the 3. So it eventually becomes Al2O3. Okay. Okay. But now before that, also sometimes you'll be asked to write sodium sulfate. Sodium. So you have an element and a radical. Sodium and sulfate. So sodium, you write it as sodium plus. Sulfate has a valency of 2 minus, so you write it as sulfate like this. So the sodium will take the 2, okay, and the sulfate will take the 1. So write it as sulfate like this. Okay, yeah. So it's that. Let's take another one. Let's say calcium and nitrate. Calcium and nitrate. Calcium and nitrate. So calcium, you write it as calcium 2 plus, and nitrate you write it as NO minus 3. So the calcium will take the 1, so eventually giving you calcium, this calcium, and the NO3 will take the 2. That's why we said radicals are a group of atoms that act as a unit. So the 2 is not given to nitrogen or oxygen only, it's given to the nitrate as well. So that's why you write it as NO3 in bracket 2. So this is something that you should know. Now, I think this is the last part. Now, in the last subtopic, which is chemical equations. Okay, chemical equations. So, for example, if you are told to write hydrogen plus oxygen, it gives you water, right, which is liquid. Okay, but now when you ask to balance this, now this is the aspect where people are getting confused. So you ask yourself, you have two hydrogens, you have two hydrogens. We have two oxygen on the left side plus one oxygen on the right side. So it means there's a deficiency of oxygen on the right side. So basically you put two here. So eventually you'll have four hydrogens and two oxygen. So there's more hydrogens now. And for you to balance those hydrogen, it means you have to write two here. Okay. Now let's take an example. Aluminium. This question that you see there below. Aluminium and oxygen. So it gives you aluminium oxide. So aluminium is 2, oxygen is 3. So let's put 2 here. Okay. But now when you put 2, aluminium will be 2. But now oxygen doesn't become 2. Right. Oxygen is 2 and oxygen is 3. Now what if we write 1.5? If you write 1.5, you get 3 oxygen, 3 oxygen. But now in terms of balancing, there's nothing called 1.5. Therefore, we need to multiply by 2. And then multiply by 2 on all sides for you to get a whole number. So multiply by 2 and then multiply by 2. Eventually, at the end of the day, you'll have something like this: 4 aluminium plus 3 oxygens, which is molecule, which is 6 oxygens eventually. So then you have 2Al2O3. So very simple question, just requires a deep bit of understanding. And I think with that we've finished the topic, and then we might meet in the next lesson, which might be next week. So don't forget to share this video to your friends so that they get to know that Mewa is there for them, and Mewa post day-to-day sessions on high school level. So don't forget to subscribe as well, for it will give a boost for Mewa as well. So with that, assalamu alaikum rahmatullahi wa barakatuh.